afternoon and welcome to the screencast on dilations. Dilations are a very important part of transformational geometry, and we've added a lot of sections on dilations in recent years because as we use transformational geometry to prove bigger ideas, such as similarity, dilations become critical. We start every lesson by logging into our Edmodo page, and we'll get right into our group, transformations number 5, our folder, dilations. As you can see here, the first thing we're looking at is Dilations Screencast. Those screencasts are all loaded into the folders and can be watched and rewatched at your discretion, and each screencast will take you through the folder of that particular lesson. Now, when you talk about dilations, we're talking about stretches or shrinks in the graph. By stretches, we mean enlargements, where the graph grows, or shrinks, we mean making the graph smaller. And important thing to remember about translations is while the shape remains the same, the size does not. When I say the shape remains the same, if we're dilating a triangle, that dilated image is going to still be a triangle. The question is has it been enlarged or shrunk? So that's where the size does not comes into play, and clearly by the term stretches or shrinks, you can certainly draw the conclusion that the size of the picture does not change. We use scale factors when dilating. I often compare it to maps or model cars or model planes, where you use the scale factor to multiply or divide and get a replica figure, but to a different size. Our resources for the dilation section is our notes. First of all, we'll go back into our online, our Edmodo folder, and open up our notes, and it tells you that when you resize a shape, it gets bigger or smaller, but it still looks similar. And if you look at the picture here, the dilated image is clearly 2 or maybe 3 times bigger. They don't give us our dilation factor here, but you can see the head and the body and everything hasn't changed. They call it resizing, but other people call it dilating. That's what we're going to stick with. But contraction, compression, enlargement, or even expansion, they're all the same idea. They just have different names. The construction of a dilation, when you're dilating about the point 0.00, is that once you have your scale factor, you would draw lines through your pre-image to your post-image, and that would make sure that you dilate the picture in the right direction. Let's take a look at the gizmo here on Math is Fun. We are going to pick our rectangle, okay, and we are going to dilate about the point 0.00, and we're going to dilate by a factor of 2.5, so it should become 2.5 times bigger. And let's resize it, and notice they're dilating out. This is going to be a big rectangle, but I think we're going to have enough room. And our new rectangle, which is 2.5 times bigger, has been dilated over our smaller rectangle. Let's change that down to a number smaller than 1. And if we dilated it exactly 1 unit, it would be a mirror image. So we'll go a half, and let's resize that figure. And they're coming in a half from where the new image was. And there's our dilated triangle, exactly 1/2 of the larger one. There are some quiz questions here in Math is Fun. We'll go back to our Edmodo page. Here's a picture that I really like of a dilated triangle, and once again dilated about the point 0.00. Our original image, we could say, is ABC, and if you look at the coordinates of ABC, A is at 0.1, B is at -1, -1, and C is at 1, -1. Now, the dilated image, you can see A prime is at 0.3, B prime is at -3, -3, and C prime is at x coordinate 3 and y coordinate -3. Now, if we compared the coordinates, you could see that the change from A to A prime was a scale factor of 3. They multiplied the points A 0, 1 by 3 to get 0, 3. Point B, which was located at -1, -1, has been dilated to -3, -3, once again multiplying each point by the scale factor of 3. And point C, which is at 1, -1, has been dilated to the point 3, -3. So we use a scale factor of 3, we multiply our original coordinates by that scale factor, and we get our dilated coordinates. Another example of a dilation from our friends over at the Smart Notebook. A dilation in the coordinate plane. In order to dilate a figure, you multiply both the x and y coordinate by the dilation factor. Look at the example below for further explanation. And it says triangle ABC has vertices A at 7, 10, B at 4, -6, and C at -2, 3. Find the image of triangle ABC after a dilation centered at the origin with a scale factor of 2. Sketch the pre-image and the image. And I just want to take a look at our pre-image points here and comparing them to our image points, and you'll notice every point 7, 10 is multiplied by 2, 14, 20, 4, -6 became 8, -12, and -2, 3 became -4, 6. They multiplied both x and y coordinates by 2 to get our new coordinates, and of course our green triangle is our dilated image. The gizmo from Explore Learning is going to launch right up here for us, and a lot of things in this gizmo. Okay, so we're going to start by selecting our triangle, and let's put our triangle, make a small triangle here. It kind of stretches over our origin point. Okay, let's make a scale factor of 2. And you can see how the triangle increases. A scale factor less than 1. There's half of the triangle. There is 1/10 of that triangle. And let's keep that scale factor of 2 and move our points of our original triangle around a little bit. And you can see the dilated points encompassing the smaller triangle, or the pre-image. And of course our dilation matrix up here, our coordinates on the bottom of our original blue triangle, 5, -10, 10, and our coordinates of our larger triangle, 10, -20, and +20. We could use our ruler to show that our original triangle length, let's see if we can make it an even number here. Well, let's just do it 22.36, and we'll measure JL 44.72. You can see that 44.72 is exactly double 22.36, and our image has been dilated correctly. We looked at our screenshots and our gizmos. Let's move on to our completing our objectives. All folder contents in the Dilations folder. We'll go back to our Dilations folder. We looked at the screencast. We looked at our notes. We checked out the gizmo. We checked out the 2 examples. And then last, but certainly not least, in our objectives folder, or our objectives list for Dilations, is to complete the quiz at the attached website. And that guy was right here. If you'd like to register at Regents Prep, you certainly can. Let's take a look at one of these questions. It says, under a dilation, triangle A, B, C becomes triangle A prime, B prime, C prime. What is the scale factor? So this one here, we're not looking at a graph. We are just, we've got our coordinates. We could certainly draw the picture. But what we want to do is analyze some points. Okay, so A at 0, 0 turned into A prime 0, 0. Difficult to figure the dilation factor with zeros, because 0 times any number is going to equal 0. How about B? 0, 4 becomes 0, 10. So we could certainly compare the 4, 10. What number would you multiply or divide times 4 to get 10? And that is 2.5. 2 times 4 would be 8. 3 times 4 would be 12. So somewhere between 3 and 4. And if you look at C, once again, they've got a 0 in here, making it tricky. But you see the x-coordinate is 6, and our new x-coordinate is 15. If you multiply 6 times 2.5, you get 15. So I would guess 2.5 is our scale factor for the dilation. And of course, they tell you it's correct, and you are able to move on. Great questions here. They incorporate all transformations It says the graph at the left shows an example of a transformation. Which transformation is shown? Is this thing a dilation? Well, to me, it certainly doesn't appear as a dilation, as the pictures, at least to the eye test, appear to be the same size. Is it a translation? Well, remember, with a translation, we don't have a turn, so it could be a reflection in the origin. And this one here, if I had to guess, would be that line over the line y equals x. We could certainly look at the coordinates and remember our image formula. The point A is at negative 4, 2, and A prime is at 4, negative 2. So I think that is a reflection in the origin, and they tell us it's correct. And once you complete that quiz, let me know if you have any questions on the quiz. And you are done with the dilations section. Let me know if you have any questions on any materials up to this point. And remember the dilations section when we get into similarity. Thank you very much.